In this video, we're going to look at solving trigonometric equations. We're going to start off by looking at two simple ones that we should have seen before, and then we're going to move on to some of the more complicated versions. So we've got two questions here, A and B. Solve sine theta equals 0.57, and as is always very important for these questions, it's within the range, within the domain of 0 to 360. Now that's important because remember that the graph of sine is periodic, it goes on forever, and if we don't have that domain, we'd have infinitely many solutions. So we have the domain to restrict how many solutions we have. So for A, if sine theta is equal to 0.57, the first thing we do to solve this is we want to find theta, and we do that by finding sine inverse of 0.57. And this will always give us the answer between minus 90 and 90 degrees for sine, and between 0 and 180 for cos. It will give us the first one, which we can see. And so in this case, we get that's 34.75 degrees. Now we have to think about the graph of sine, which looks like this, to find any other solutions. And we can see on here, in this domain, 0 to 360, there are two solutions, because they're coming across about here. So there are two solutions. The first one, which is the one we've already found, and the second one, which we need to find. And the way we find that is by symmetry. So by symmetry, we also have that theta is equal to 180 minus 34.75. Now make sure you know where that's coming from. It's because we're 34.75 away from the 0, so we need to be 34.75 away from the other 0. And that gives us an answer of 145.25. Now you should always write your final answer with the whole list of them at the end. So theta is equal to 34.75 degrees and 145.25 degrees. So that's your final answer here. For part B, we do much the same thing, but this time it's cos. So we've got cos theta is equal to minus 0.3814. So first of all, we do theta is equal to cos inverse of minus 0.3814, and that gives us an answer of 112.42 degrees. Now when we consider the graph, remember cos starts at 1, cos looks like that in the domain of 0 to 360, and we're looking for a negative answer. So actually this time we're looking for something down here. And we've got the first one is 112, and we need to find the second solution. And again, this time it's by symmetry. Now with cos, we can either find how far away it is from the 0, or we can find how far away it is from the maximum, or in this case we can do 360 minus. That one works quite nicely here. So we also have by symmetry, theta is also equal to 360 minus what we got before, 112.42, which is equal to 247.58. So we have that theta is equal to 112.42 degrees and 247.58 degrees. Now those skills are really important, and we're going to go on to look at some harder examples now, but they're all going to make use of this skill. So in example 2, we have this equation here. 3 cos squared theta plus 2 cos theta is equal to 0. Now the first thing to note here is what do we mean by cos squared? Cos squared theta is the same as cos theta all squared. It is, we don't write it just cos theta squared because that would look like the theta was squared. So cos squared theta actually means cos of theta all squared. And that's something really important we need to use here. And what we can actually see here is both terms have cos thetas in them. What that means we can do is we can factorize out a cos theta, which leaves us with 3 cos thetas here, because cos theta times cos theta is cos squared theta, and it leaves us with a 2 at the end. Now we've got 2 parts to this. We've got cos theta, and we've got 3 cos theta plus 2. And each of those could be equal to 0. Because if we've got 2 things multiplied together and they equal 0, one of them is equal to 0. So we either have cos theta equals 0, or we have 3 cos theta plus 2 is equal to 0. And cos theta is equal to 0. We can find the answers to that. And what I'm going to do is I'm going to draw my graph of cos over here again. Quick sketch graph, we're going to use that a lot. When is that equal to 0? Well, that's equal to 0 here and here. So that's when theta is equal to 90 and 270. That was nice and easy. This one we need to rearrange a little bit. First of all, we subtract the 2, and then we divide by 3. So we get cos theta is equal to minus 2/3. And this one is then like what we had on the previous page. Theta is equal to cos inverse of minus 2/3, which is equal to, and we put that into our calculator, we get 131.81. Minus 2/3 is somewhere down here, so that's that one. So we need to find the other one. By symmetry, we have theta is equal to, say, 360 minus 131.81. There are other ways to do this by symmetry, but this is one way. Gives us 228.19. And then finally, we need to write down our final answer. So our final answer is theta is equal to all the possible options. And we normally write these in ascending order. So 90 degrees, 131.81 degrees, 228.19 degrees, and 270 degrees is our final solution there at the bottom. Now let's move on to example 3. Now here again we have cos squared and cos, and a number this time. And what we need to spot is actually, this is a quadratic in disguise. If we rearrange this, so we get 6 cos squared theta plus cos theta minus 1 equals 0, we can see this is a quadratic. We have something squared plus the same thing not squared plus or minus a number equals 0. So we're dealing with a quadratic equation here. And the way we solve quadratic equations is we factorize them into 2 brackets so that we can solve them. So when we factorize this, we get 3 cos theta and 2 cos thetas. They multiply to give us the 6 cos squared thetas. We get minus 1 when we do the other 2 numbers, so these both have to be 1 to give us a 1. And we need a plus and a minus. Well, we need plus 3, so this one needs to be plus, minus the 2, so that one needs to be minus. And what this tells us is, again, either the first bracket or the second bracket is equal to 0. So we have either cos theta is equal to a third, or we have cos theta is equal to minus a half. So once again, if we draw our cos graph, we're getting quite good at sketching this now. We're interested in when it's equal to about, it's equal to a third. Well, that's about here, coming through here. So there's going to be 2 answers for the third, for the red side, and for the green side, when it's equal to minus a half, well, that's coming through here. Again, there's going to be 2 answers. So in total, we're looking for 4 answers within the domain 0 to 360. Remember to keep checking that. Is it 0 to 360? With 0 to 720, we'd have 4 more answers, so 8 answers in total. So now let's solve each of these. For this one, we get theta is equal to 70.53 when we do the inverse, and by symmetry, we get theta is equal to 289.47. Double check that you can get that answer by symmetry. If you can't work out how to do it, go away and think about it. For the cos theta equals minus a half, using the calculator, we get it's equal to 120. Actually, this is an exact value one. And again, by symmetry, we get 240 there. So that gives us our final answer of all of them put together is 70.53 degrees, 120 degrees, 240 degrees, and 289.47 degrees. Final answer, 4 solutions, which is what we saw in the graph, 2 red and 2 green on the graph. This is quite common to have quadratics disguised in trig equations. So look out for them. If ever you see a squared trig term, you're probably looking at a disguised quadratic. The final example is a little bit different. This is the final type that we can see in this section. And this time we've got sine of theta minus 30 inside the bracket is equal to 0.4. Sine of theta minus 30 degrees is equal to 0.4. Now we could do this by considering the transformed graph, but actually what we're going to do is we're going to make it easier by replacing what's inside theta. We're going to let phi be equal to theta minus 30. And that means we're now dealing with sine of phi is equal to 0.4. Now that one's much easier to deal with because we know how to solve that. It's exactly the same as we've already seen. So we get phi is equal to 23.58. And we'll get other ones as well. So if we consider the graph of sine, sine does this. And if it's equal to 0.4, it's coming through here. If we found the first one, we still need to find the second one. By symmetry, we get that phi is also equal to 156.42. But that's not our answer. That's our answer for phi. We wanted theta. Now if phi is equal to theta minus 30, then theta is equal to phi plus 30. So we still need to work out theta. So theta is each of these results we already had plus 30. So it's 53.58 degrees and 186.42 degrees. Now again, we need to be a little bit careful here because we need to make sure there wasn't another result that would have given us this when we added 30 to it in the domain. So if we think about it, if we carried on sine down here, would we have got another one that if we added 30 to it, it could have been equal to that green line? Well, no, because below there it's below, so it's always going to be negative. So there are no extra solutions here. What we would have needed to be careful of was if it had been the other way, if it had been plus 30, and we had to minus 30 at this last stage, we would have had this bit of graph here, and we could have had an extra one here that may have counted. We'd have to check that. It also could have been that this one here, when we took the 30 off, if it had been that one we were taking 30 away, the 23 minus 30 would actually have gone below 0, so it theta wouldn't have then been in the domain, so that one wouldn't have counted. So you have to be very careful here. Make sure your final answers are within the domain. If you're not sure, go one extra, do an extra one either side, find the extra ones outside, and then eradicate them at the end. So this is how we solve some examples of trigonometric equations. The simple examples in example 1, a couple of quadratics, disguised quadratics, which settle down to simple trigonometric equations once you've got rid of the quadratic part. And then finally this one, where we let phi equal the bit inside the function to work it out, and then we have to adjust back at the end to find the values of theta. And always, always, always remember to be very careful to check the domain that the question is asking you to work within. All of these ones were 0 to 360, but that is not always the case. So check it very carefully to find out what the domain is.